Hello, everyone, and welcome to today's session. Today, we're going to be discussing really interesting stuff, and the title that I have given for today's session is that Understanding the Data. Before this session, we have discussed about machine learning lifecycle, about machine learning basic tools, and in the previous session, I have discussed about how to import data and how to read them. Okay, today we're gonna be seeing the next step after collecting the data. Okay, so I have mentioned in machine learning cycle, when you build a machine learning model, first of all, what do? As I mentioned, you collect data, that is data collection, right? After that, what do? You do something called data pre-processing. After that, you get a processed, a refined, a clean data set, and with that clean data set, you do something called model training. You train the model, whatever machine learning model you want. Okay. Now, thing is, do we really go from this to this and this to this? Yes, of course we go, or the flow is like this. But what is the relation uh, of our topic today? Understanding the data. Where does this part come? Well, before we go from data collection to data pre-processing, we need to know about the data, right? If we don't know what is the data set about, what it is trying to tell us, and what is it about, then how can we pre-process, right? We are going to be doing the pre-processing stuff on the basis of our understanding of the data. And this is where, in the middle ground, something comes, and it is a term called EDA, and it stands for exploratory data analysis. Okay, so here the term itself is kind of explanatory. Okay, it is itself saying what does it mean. We're gonna be doing data analysis. Okay, now you might be wondering that why do we need this stuff? Well, as I mentioned, when you collect data, most often it will be, uncleaned data, and there are gonna be some irrelevant stuffs in the data, irrelevant, and etc., which will make your model inefficient. Okay, it will make your model inefficient, plus it will give you wrong outputs. So it is really important to clean data, to know about data. Okay, not only that, but also there are some troublemaking points, some uh, uh, some irregularities, some problematic stuffs that can cause these things. Okay, so let me title some troublemakers in our data sets. Okay, like there might be null or NaN values. That means there's nothing in that. In the cell, this data is empty. There's nothing inside. There might be duplicate values. Okay, there might be different kind of data types. You're using integers, and suddenly you get something string. Okay, There might be like irrelevant data. Now you are working with a purpose, and there are some data which are completely irrelevant to your purpose. Those have nothing to do with your outcome, your project, your goal, anything. Okay. So like this, there are some other stuffs, etc. These type of things are troublemakers. Okay, these can make your model inefficient, inaccurate, and totally make your project flop. Okay, so these are the villains here. These are the villains. Now, how do you know that these are present in your data set, or how do you identify them? Okay, or how you know how much, in what quantity they are in your data set. And this is where our detective EDA, that is exploratory data analysis, comes in. We do this basically, just do data analysis to find out if there's any null values, non-values in our data set, any duplicates, any different kind of data types, irrelevant data, or maybe any other troublemakers are present in my data set. We will be identifying them. Plus we will be finding other stuffs, that what is the data set telling us, what is its size, how big is the data set, are all the columns or features relevant to my project, etc. So all of the stuffs we are going to be doing in EDA, that is explanatory data analysis. Clear? Okay, fine. So we have discussed that EDA is something between data collection and data pre-processing, basically analysis. And I have discussed now that why do we need to do that. Okay, now EDA, there are some you can say a classification, okay, if you want to put it that way. How you can do the analysis, something called univariately, okay, or you can do it bivariate or multivariately. Now you might be wondering what are these terms. Well, let me get there. These are nothing but terms, okay, terms of uh, data analysis classification. Let's get to the first one, that is univariate. Suppose this is a data set and we have four columns, A, B, C and D. Fine. Okay, now if we do our analysis with only one column, suppose this column, we are not thinking of anything else, nothing else, then it is called univariate. Okay, if we are dealing with any two column, any two, it might be A and B, B, C, or A and D. If we are dealing with two columns, then it is bivariate analysis. We are comparing between two columns. If it is equal, if it is greater than, smaller than, what are the percentage of errors among these two, etc. We are just doing analysis on two columns, then it is bivariate. And if we do more than two, it will be called multivariate analysis. Let me just write it down. If it is one column, you'll call it univariate. Two column, you will call it bivariate. If it is two plus column, then it will be a multivariate analysis. I hope it is clear to you. Now, through this analysis, we get an idea of our data set. We get some information, some knowledge about our data set. And among these information, some information might be attributive. Okay, some might be attributive and some might be statistical or mathematical. Statistical or mathematical. Now, what might be attributive? For instance, what is the length of the data set? It is a kind of an attribute of the data set, right? That's why it is attributive. Or what is the max value here in your data set, or the minimum value in your data set, right? These kind of stuffs are attributive information that we get from the data analysis. And for the statistical part, like what is the range of your data from what to what is the variance of your data set, okay? Or like what is the distribution of your data set, okay? This type of things we can also find these through the analysis, through graphs and stuffs. These are statistical information and really important as well, okay? And another thing is very important that we are going to see is that through the analysis, or should I'd say we can do the analysis by using only mathematical functions or methods, or by seeing math outputs, or another thing, it is more efficient, that is using graphs and plots, okay? Math is just numbers, right? But if you can visualize those, it gets easier for you to decide, right? Ultimately we have to decide what to keep and what to not, what to add or not, or how to manipulate the data, okay? Math means it will be just numbers, okay, random numbers, and the graph will give you an idea that actually how is the data, okay? It is a instrument of making your understanding of the math easier, nothing more. Clear? Okay. Now what's the agenda for today? Well, as you can see, there are two types of data analysis that I have mentioned: univariate and bivariate or multivariate. We are going to discuss these two in the upcoming sessions, but for today we are going to give an overall analysis, okay? We're going to make an overall analysis of a data set. We're not going to be going through a single column, okay, or comparing it with others. We're just going to have an overall idea of the total data set, okay? An overall analysis of the total data set. Clear? And in the coming sessions we're going to also discuss the univariate and bivariate multivariate part. So yeah, let's get to the hands-on. Let's go to our notebook, Jupyter notebook. So these are the agenda, the topics and functions and stuffs that I'm going to discuss. So first let's import the necessary libraries. Obviously it's going to be NumPy and pandas. Let's run it. And since we are gonna use Titanic dataset, I'm gonna use Titanic for this session for the example. So let's import Seaborn. Import Seaborn as SNS to get the Titanic dataset. Okay, let's call it DF. And I have told you in the previous session that how can you get the pre-installed inbuilt datasets by using websites, by using different Python packages, okay? So here I am using a Python package called Seaborn. As simple as that. We're gonna write Titanic. There are other datasets. Please go and see the previous lecture or session and you will be ready to use them, okay? Fine. Let's see the dataset. Let's run it. Yeah, here you go. This is the Titanic dataset. Fine. Okay. Now, at first, at the beginning of our analysis, what are we going to do? First of all, we are just going to do some basic, let me write it, some basic analysis. Okay, some basic analysis. Let's do those. Among them, what might be a basic analysis? Like here you can see that it's a large data set. Now, how do you know it's a large data set? You can see the shape of it, right? How many rows and how many columns? You can see it here as it is mentioned. But we can also find out that by using a function or attribute called shape. Let's run it. Yeah. It perfectly points out what is the shape of our data set. It is 891 rows and 15 columns. Clear? Fine. It is a large data set. Okay, so viewing it is a bit difficult, right? So let's shorten it a bit. Okay, let's look at the first 5 rows, and the function to use is called dot head. Here the parameters you can see is an integer, that how many rows would you like to see. So suppose we'd see 5 rows, and here you have the first 5 rows. Now you want to see the last 5 rows, so the command is tail, and the input here is also an integer, the last 5 tail values. So it is the last 5 rows of our data set. Clear? Okay. Now another thing is that the data set might be biased. Okay, like in the first portion of the data set might represent something, the last portion might represent something, and the middle portion might represent something. Okay, let me show you it in the notebook. In the Yeah, so suppose this is your data set. The first half, the first about is topic A, suggests topic A. The middle part suggests topic B, and the last part, the third part, suggests something called C. Now, if I do dot head 5, I will only get to look at the values of the first portion, right? Or if I do dot tail dot 5, I will only look at the last portion, that is the C, that indicates our C value. And based on this, if we do something, what will happen? We will completely ignore the B case, because we haven't looked at the B anywhere. Okay, we'll get an assumption that there's nothing like B in our data set, right? This is why we need to see random values from the all dataset to have an overall idea. Okay, to do that, there's also another function. It is called sample. Similar parameters, but what it does is that it randomly picks 5 rows for you. Okay, it randomly picks 5 rows, and if you refresh it, it's gonna refresh the rows again and again and randomly pick 5 rows for you. Okay, this how you can easily get an idea, overall idea, that how is the data set throughout the whole data set. Okay, not in any region, the first part or the last part, throughout it. Clear? Okay, it is very important. Next thing is that when we work with dataset, knowing the uh, data types of each columns is really important. Okay, so how can we know that? Another command called df.dtypes. Let's see. Okay, I it might be d type. Okay, let's see what's the error. Okay, let us see. I have a, okay, okay, it's an attribute. I have given the bracket here. I've given the bracket here, D type. Still not coming. Okay, what might be the problem? Data type has no D type. uh okay, I missed the S again. Okay, let's rerun, and here we go. It is giving me all the data types of each column. Okay, clear? Okay, this is the analysis that you do, understanding the data, what which column represents what. Okay, like in survived, all the values are integers. Okay, in age, all the values are floats, like this. Okay, and string is represented as object in pandas. Okay, it's not exactly the same, but assume it is the same. Okay, it's fine. What else? Well, here by using df.dtypes we get to know the data types. Okay, uh, now let's have an overall summary of our data types, all the data set. Okay, for to see the overall summary of our data set, we can use these functions. Okay, okay, let me show how. Suppose okay, we already have our data set df. Let's see it again, the beautiful data set. Now I want to see all the columns. We can do that. Dot columns, all the 15 columns are listed here. Fine. Now as I said, I want to know or have an overall idea of the structure of the data set. For this we can do a command called dot info and run it. This gives a further details about the data set. As you can see, it is giving all the columns and including the value, how many values are there. 891. Okay, in this age column it has 714 numbers. That means there might be some null values. It is only indicating some non-null values, as you can see here, right? And it is also mentioning the data type. Okay, fine. So by using the dot info we get an overall idea. Here is also the range, 891 entries, that means the row number, and it is ranging from 0 to 890 index. Okay, fine. So this is one type of summary of the whole data set. Let's have a bit of mathematical summary. Okay, like a column, what is the max value, what is the minimum value, what is the average value. Okay, this type of statistics we can also do that by using describe function. Let's run it. Here we go. It is giving us the statistics related to the numeric columns. All the columns that you see here are numeric, not categorical. Okay, I hope you know what is numeric and what is categorical. Numeric means you get 1, 1.2, 3 numeric, and categorical is category A, B, C. Okay, these are categorical. Fine. Okay, so describe shows us the numeric statistics of each columns, like the count, how many uh, valid inputs are there, non-null values. As you can see, what is the minimum value, what is the standard deviation, the 20%, what is the 20% of the whole data, of the whole column, the max value, as you can see. So it makes so easy for us to see the whole data set at once, right? Such an amazing feature. Another thing, if you want to add the non numeric columns as well, there's a parameter, if I'm not wrong. Let me check, I've forgotten it. I have written it here. Yeah, include all. To include all the columns regardless of the numeric or not. Now you have a total list or total presentation of whole data set including the numeric and non-numeric columns. Clear? Okay. So what's left? Okay, and what up until now what have we discussed? Let me give you a summary. Okay, before that let me check if my recording is going on. Yes. Okay. Okay, fine. Okay, so up until now in our EDA, what have we done? We have seen the basic analysis. Okay, analysis. We have seen the heads of the data set, the tail, and also took some sample randomly to see the overall or have an overall idea. We have seen the columns of the data set, right? And then we have gone a bit further. Okay, and in this part we saw an overall view by using .info, overall information of the data set, and a mathematical presentation, mathematical overview by using describe function. Here I forgot to mention another thing. Let me add that. That is, you can also have a view of the unique values. Okay, like in a column, let me give you an idea. Suppose this is a column called A. You have values called 1, 2, 1, 2, and 3. Now, how many unique values are there? 1, you have 2 and 3. So 3 unique values, right? We can find this column wise by using a function, and that function is called something called value count. Okay, it will show us unique number of total categories, if I say. Okay, let's see it. Let's use it to show you. Let's go down and use df.value count. Let's run it. Let's wait a little bit, and okay, there's an error, value counts. Okay, I made an error here. It is value counts. Let's try it again. Yeah. Okay, it is giving you an overall view. It looks a bit of messy. Okay. Okay, let me take one column so you can see it properly. Like, let's take us what, which columns do you want to take? Let's take a categorical column. What to take? Let's take who. Let's see what the output is. So to do that, we're gonna select who and run it. Yeah, there you go. In the who column, we have 3 categories of answers: men, women, and children. And among them, there are there are yeah, as you can see, there are 537 entries of men, 271 entries of women, and 83 entries of children. Clear? In the who column. So this is how you can get the total unique values of each columns as well. So easy, right? Okay, what's next for our analysis? Let's see. Now, as I mentioned, in data analysis, it is really important to find out the non-values. Are there any non-values, any duplicate values? Okay, and we can look it by using these functions. Let's see them hands-on. As I have mentioned that if we keep these things, the non-values, the duplicate values, it hampers our overall model. So it is really important to eradicate or manage these things. So for data set, we can use null. Okay, okay. Is null. The command is null. Okay. The is null command is showing that if there is any null non-value, there will be true and otherwise false. As you can see here, see true. This is meaning in the DAC column at this row, this data is none. There is no data entry in this cell. Clear? Okay. Now if you want to have the total of the non-values, you can add a sum at the end, and here you go. So in the deck, so many values are missing. Oh man, this is a real issue here. You have 891 values. Among them, I think it is 80% are missing. So this is really important. If you keep this column like this, your model is obviously going to give you wrong answers. You get my point? Yes, this is how important this stuff is. Okay. Similarly, let's find out the duplicate values. Is there any duplicates in our column, in our data set? Duplicate. Okay. What have I mistake? Duplicated. Okay. Duplicated. Let's run it. Well, there's no duplicated values. Let's do a sum. Okay. There are in total 107 duplicate values here, somewhere in our column. If we just ran the duplicated function, sorry, it gave us the output of each row wise. Okay, so it is printing all the 890 rows. But if we want to just have a sum, we can do the sum function at the end, and it will give you the total number of duplicates in the data set. So this is also a huge number of duplicates in our data set. So obviously something needs to happen in this. These are troublemakers of our data set. Yeah. Okay. What else can we do in our analysis? We can use another function called unique. Unique. It is like the value count. Okay. It is like the value count, but it is giving how many categories are there. Okay, let me clarify it. Like in value count, it gave you how many categories, it means category number, and in each category how many entries, total entries. Okay, but in unique, it is only giving you the category number, how many categories are there in your column, but not going for the total entries in each column. Clear? Okay, let's see that. In survived, we have only two type of entries. In sex, we have only two type of entries, male and female. Like this, you can see. Fair is varying too much since it is a float variable. Everyone will have different kind of payments, so it is quite obvious it's going to be a huge number here. Clear? Okay. So let's see anything missing in this part of our discussion. We have discussed about is null. Oh, another thing, you can see the percentage by using this command. Let's see it. I have seen the sum, right? I have seen the sum total value of the missing values by using is null. But if we want to see it as percentage, we can also do that by using this. And here you go. There's 19.86% of non-values in the age column. And I have told you that it might be 80% of non-values in DAC column. And this is the proof. It is almost 80%. See it? 77.22. Wow. This is huge percentage of non-values in this column. So this is how you can do this type of data analysis. Okay, so let's go to back to the top. And by far I have shown you basic data exploration and these functions. I have shown you overall summary and these functions. Now I have also shown you the data inspection part and how to do that by using these functions. Okay, it is suggesting column wise. I've shown you that how to use unique, and here you go, the value counts as well. Clear? Okay, now not too much topic remaining. Another topic is you can also see the memory usage, okay, of the data set. As you can see here, memory usage. Let's copy it for our ease and print it to show you how this works. Let's print it. Yeah, each column it is showing how many kilobytes, if I'm not wrong, how many kilobytes of data are stored in the memory. If you look at the doc string, and yeah, returns the memory of usage of each column in bytes, not kilobytes. It is B in bytes. Okay, not in kilobytes. So it is too little, not even kilobytes, it is in bytes. Really small uh, expression of quantity. Clear? Okay, and if you do this sum, then it will show you the total memory space that it has taken in bytes. Clear? Okay, fine. And what else analysis can we do? Let's see our list. And it is really important, data distribution and imbalance. Okay, what does this mean? Before that, I have to give you a bit of theory lecture here. Now, what is distribution? Distribution means, like, this is a graph and these are some data points. This is a distribution, how the data points are distributed along the graph. Clear? This is the distribution. But by looking at this overall view, we can't have a proper idea that how is the data inputted. Is it good for us or is it not good for us? So we can decide this thing statistically, and there is something called skew. Okay, let's talk about skew, a new term for you. It is a statistical term. A data is called good or really good, okay, if it is a shape like this. Let me draw it again. Okay, this is called a bell curve. If the distribution is giving you a curve like this, where the peak is in the middle of the graph, then you call it a good distribution, perfect distribution, and it is also known as normal distribution. Clear? Fine. Now, this is the ideal state in which all of our data, the columns, we want to be. But we know the data are not going to be cleansed. There will be some flaw, right? That's why the graph might also look like this, or even look like this. See this? The peaks of each graph is towards the left portion or towards the right portion. This indicates something. Okay, if the graph is like this, it is called right skewed. Right skewed. It is indicating that most of the values are in this range. Okay, and very few values are in this range. Clear? And as we know, the x-axis indicates the growth, right? It starts from here 0 and it goes to infinity. Be very attentive here. Again, let me clarify. In this bell curve, we see the curve is on the top or in this range. This means majority of the data set are in this range. But this doesn't mean all of the data set, because this portion is still not in that region. But the amount is little, this is why it is going downwards. Not too many numbers are in this range, This is why there is no peak in this region. There are numbers, but they are not too many. I hope I am clear on this portion. Okay. Another thing that you have to remember, if this down portion, the down slide, the longer it is, the greater the value of those numbers in this region. Clear? Like suppose if the downslope ended here, that would have mean that the value of the values or data points in that downslide is in this x. It doesn't go further, it is stuck on x. But if it went further, like in y, that would mean x is less than y. The values ranging from this portion are getting bigger and bigger in magnitude. Okay, let me again in a freshly, let me explain. This is a really typical or technical term. This is why I'm taking a bit of time here. This is our rightly skewed graph. Wait. Okay, the top portion or this portion indicates the majority of the data are in this region, but the rest of the data from this portion to this portion are left. Okay, there are data set, but the amount is not so much. This is why, since the amount is not so much, this is why there is a down slope. Clear? Okay. Now in this down slope, the max value is up until here. Suppose this is x. Clear? Now if the down slope kept on going like this, kept on going, it stopped here in y, then it would have mean that the y downslope had greater value than the x one. And also all the data set ranging here, it is greater than the z data points. Clear? Basically it is meaning the farther the downslope goes, the greater the value of the data points in this region, and these are dominating greater than this portion. The overall data is kind of dragged to the right part. As you can see, it is dragged to the right part. Most of them are sitting here, but for this downslope, the further it goes, the more it drags to the right. This is why, this is the reason why it is called a right skewed graph. Clear? Similar to that, we also have a left skewed graph. This is going to the left or indicating the left. That's why it is a left skewed. Clear? I hope I have made it easy. Okay. So since, as you can see, it is a graphical term. If we can see a graph out of it, it will be easier for us to understand. And it is actually the fact. But since we are not going into the graphs in today's session, we will be seeing a mathematical expression of the same skew. Let's see it. Let's go. Let's create, and the function is df.skew. Let me check the spelling. I have made several mistakes today in the spelling part. Skew, okay, skew, and that's printed. And you can see the closer to 0 means closer to ideal range. The ideal range is this, as you can see. This is the ideal. This graph is the ideal range. This is the 0, the medium part. Okay, so as close we can get to the 0, that means we are having a better distribution of the data points. Clear? As you can see, this is closer to 0, which means good. This is closer to 0, this is also good, but this is 3, this is 4. This means it is too much right skewed. Okay, okay, fine. And it is also a problem. This thing, right skewed or left skewed, causes bias in the data set. Okay, it will completely ignore a huge portion of your data completely. Okay, this is why we need to tackle this problem so that we don't get anything biased in our data. Clear? Okay. And another thing that I can show you, and this is the final one, it is variance. This shows the variance of the data set. Okay, variance is nothing hard. It is basically how much you are deviating from your mean. Let me say it, mean. Okay, there are some technicalities or mathematical, I'm not getting into too deep. The how much you are deviating, are you getting here in 50 or you are varying to 100? This is an overview of the variance, and this is indicated in this output. Okay, as you can see, the fare is varying too much. It is going to almost 2500. Okay, so it is really high, the variance is really high, and it is obvious because it is money. It will be different for everyone. So yeah guys, this was today's session, exploratory data analysis part 1. Remember, it is part 1. In today's session I have discussed, first of all, I have discussed what is EDA, why do we need it. Then I have discussed the classifications, like what type of EDA do we do. And today I have given you an overall EDA on Titanic dataset. and what things that I have told you, I have given talked about all of these topics here, from basic data exploration, giving an overview summary, from data inspection, memory usage, data distribution. Another thing is data relationship. Let me cover it also. It is also simple. It just gives you df.core, gives you the relation. It is kind of a multivariate analysis, like how this survived column is correlated with the age column, how it is related with purge column. Similarly, how age is related with p class column, with fair column. Okay, the positive indicates it is positively correlated. It increases when that increases. The negative indicates it is negatively correlated. It increases when that decreases. And if it is 1, perfectly 1, that means the both are exactly the same. Clear? This is the correlation graph. It will be very easy for us to visualize this is why I'm not getting too deep on it. We will be discussing in our multivariate portion. There you will see a wonderful heat map to fully understand what the data is actually telling us. So yeah guys, this was the whole story of today's session, and let me remind you, in the coming sessions I will be discussing univariate and multivariate analysis. So if you want to have a total idea of exploratory data analysis, don't miss the next sessions. And this is it for today's session. Yeah, bye bye, see you later.